All right, here we are. So there's a few things we have to do today. Now, first things first, you know that the midterm is due next Monday at midnight. It's on Moodle as we speak. In fact, let's see if I can find it. Oh, maybe not. It's kicking around here somewhere, but it's on there. And so what we still
Under
have,
course materials. Like
it's
If you go on Moodle, it's under course. It's under course materials at the top, and it will say like midterm MT1 at the very bottom.
okay, good. All right, just want to confirm that. Um, Here we go. I thought I had it open. So
I'll use that one.
once you've got all this stuff open, it's very hard to find anything. Especially, I don't know why Moodle. For some reason, I just find it hard to notice it from all my different open websites.
You can bookmark it. You know what the bookmark page is? Like add it to your favorites. That's what I did.
Oh, all right. Well, I'll try that.
Those are what I do with all the Zooms.
Really? Okay. I'll look into that. As usual, I'm so far behind the technology curve that I don't know about these things. But anyway, here it is. God, we finally found it. Let me just make sure this is the right course. This is us. Okay. All right. Yeah, it's down there at the very bottom. So it is there. So when we're done, now today we have to finish up the sample midterm. We were not completely done with it. We'll wrap it up today. And so, you know, some people have already started sending these in. I mean, you don't have to wait until we're done today. You can send it in as soon as you want, but just remember, try to have them all ready by midnight on Monday. And as I said before, send them to my purchase email account. If you forget, it's not the end of the world, but try to remember to send it to my purchase account. It just makes it a little easier for me to gather them up and find them all. Also, of course, make sure that when you do take pictures of your work that it's legible. You know, the cameras are fine, but if you have poor lighting conditions, or if your hands are shaking or something goes wrong, or if it's just too small, that happens too. So just be careful and make sure that they look right when you send them to me. And that'll make things a lot quicker and easier for me to correct them. That's for sure. And so the quicker and easier they are to correct, the quicker the quicker I'll correct them. Okay, so let's go back here and finish up what's left of our second midterm, sample midterm, I should say. And so let me get that open for you. That should do it. Well, let's open it up and look. Are there only 7 questions? I wasn't really paying attention to that. It's possible. Oh, you're right. No, there's 8. Ooh, there's 8. Okay, so yeah, as long as it says midterm 1 or midterm, just plain midterm here, but the title of the document is MT1 because there's another one that we'll have, you know, later on, of course. Okay, this is the one. And you can see it's basically just a shorter version of our sample midterm. Okay. So that way you know exactly what to expect. If you know the material, you'll do just fine. All right. All right, now let us get back. Oh, yes, we have to finish up the sample midterm. This part we were not done with. There's a few questions at the end that we didn't quite get to. So we'll take care of that right now. Let me just add a few details here. Today's the 11th. Okay, so where we left off with was, we didn't quite start our FOIL problems. All right, so here we go. Let's do FOIL. FOIL is kind of fun. So we'll do that first. All right, so of course, as usual, we all know what FOIL means: first, outer, inner, last. So we just have to be careful. There's nothing terribly complicated about this. So here's F first. We have 8x cubed. O would be these two. 14x squared. Let me just put a little extra space in here. There we go. Okay, inner is these two. So that would give us negative 12x. And then last would be these two, negative 21. Now here, in this case, oh yeah, go ahead, Britt.
Should we write them in like order of exponent? Like, so like anything to the third power, anything to the second power, anything to the first power, and then nothing?
Yes.
Okay.
That is the ideal. Now, if you forget to do that, I'm not going to take points off, but yes, ideally, that's what I would like to see. Like here, for example, the x cubed, x squared, x, and then the constant. This would be the ideal way of writing it. It's just easier. And by convention, we always try to put it in this order. All right. Also, it makes it quicker for me to correct it too. There's no, that's part of it too, but that is the standard form for these polynomials, as they're called. All right, now let's try this one. F is 35x squared. O is minus 10x. I is minus 21x. Last is 6. Okay, so this time we can combine these two. So let's do that. And that's it. That's as simple as it's going to get. And so if you got that, then you have it absolutely correct. All right, now how about the third one? All right, FOIL. All right, here's F minus 8x to the fourth. O, 4x squared. I, minus 12x to the third power. And then last would be these two, which are 6x. Now here we can't combine these. And so we would like to change the order slightly so that the x cubed term comes after the x to the fourth term. Then we'll have the x squared term and then of course 6x. That would be the ideal. This is the correct format for that. All right. So I think we're all getting pretty good at FOIL. One of those skills that doesn't really abandon you, but it's always good to practice, don't you think? Of course, everything you get better at everything with practice. There's no exceptions. All right, now the factors. So remember what we're trying to accomplish here. We need a pair of integers whose product equals 12 and whose sum is negative 8. Okay, because this is the constant. The coefficient is negative 8. So what you can do is pick the integers whose product is in fact 12. And when you've written them all out, you'll see that one of them will have a sum of 8, negative 8 actually. All right, so we'll have 2 and 6, negative 2, negative 6. Now you don't have to write them all out if you find the one you're looking for. Like here, for example, we could carry on a little further and put 3 and 4. But we don't really need to. We found the ones we're looking for right here. This pair has what we're looking for. Their product is 12, but their sum is negative 8. So that means we can write x minus 2 x minus 6 is 0. Those are the factors. Okay, we don't need to solve. All we know is that, in fact, even this part isn't necessary because it's only asking for the factors. What you could just do is say, well, all right, well, let's just leave it like this, but let's just note that the factors are x minus 2 and x minus 6. But if you write it like this, that's fine. I'll know what you mean. Okay, now how about this one? We have x squared minus 6x plus 8. And let's see what we can do with these. So we need to find a pair of integers whose product is 8 and whose sum is negative 6. All right, so let's see what we can find. Let's see, 2 and 4. Okay, here we go. Negative 2 and negative 4. So the factors are x minus 2. We can say that this equals 0. And therefore, the factors are actually x minus 2 and x minus 4. All right, so those are pretty straightforward. Now we get to use the quadratic formula, which is one of our favorite formulas, I think we can all agree on. So it's one of those formulas that you can look up. I mean, when you're doing this exam at home, you'll have all your notes in front of you. But I find that most people do not forget this formula anyway. So we have x1 and x2 equal minus b plus or minus the square root of b squared minus 4ac over 2a. And also we note over here that a equals 2, b is negative 12, and c is positive 16. All right, so let's plug those in. And again, as usual, you must be extra careful with these negatives. Okay, so let's see what we've got. 12 plus and minus. Negative 12 squared is 144. Now from that, we're subtracting 4 times 2 times 16, which is 128. And then we'll divide all that by 4. Okay, so we'll have, oh, look at this. We have a perfect square. So this is actually the same thing as 12 minus 4 over 4, comma, 12 plus 4 over 4. Whoops. So then we have 8 fourths, 16 fourths, and this reduces very nicely to 2 and 4. And that's it. Now, if you want to, you can double check. All you have to do is plug in each of these into the original function and or equation rather, and you'll see that they both give us a solution of 0. Okay, so either one of these substituted into the original equation will give us back an answer of 0. You don't have to do this, but it might be a good idea, especially since you're doing this at home and you have time. In the classroom, then maybe you have to be careful with your time, but here you do have the leisure of double checking your answers if you feel like you want to do that. Okay, but that part is not mandatory. Now, by the way, don't forget about this little detail. If you write out the steps like this and you make a mistake somewhere along the way, I can give you a lot of partial credits. If you just write an answer that's wrong, well, there's not a whole lot I can do about it. So you don't have to go nuts, but just try to write down at least some of the steps that you followed so I can follow along with your logic. it's really just like an insurance policy. If you got it right, you got it right. That's it. But if you got it wrong, I really would like to know why, because it might be something as trivial as you missed a negative over here or something like that. And that threw off the whole thing. So if I can see what happened, then I can help you out by giving you partial credits. And I'd like to give out partial credits. You know, I hate to see people lose points because they missed a negative, but you have to help me by showing me what you've done. Okay. All right. Now here, A equals 2, B equals 6, C equals 4. And of course, our favorite formula in the world is all right. Now, wow, we don't seem to have a whole lot of negatives this time. What's going on? So we have 36 minus 32. Then we have minus 6 plus and minus 4 over 4. And once again, we got ourselves a perfect square here. All right, so this breaks up into two pieces, negative 6 minus 2 over 4 and negative 6 plus 2 over 4. And now that leaves us with minus 8 over 4, comma, minus 4 over 4, which means negative 2 and negative 1 are the solutions. Beautiful. So these were particularly nice equations. You see how we got nice results. No radical 13s in this down here, that's for sure. All right. All right, what's next? Oh, the word problems. This is nobody's favorite section of the test, I think. I think you'd rather do quadratic formulas, but we can't always do quadratic formulas. We have to have word problems because at some point we need to apply this material to something. And that's what the word problems are for, to see what we can do with these ideas. Now, this one is a simultaneous equations problem. Yeah, I know. I think most people probably would. Most people, or don't worry. Oh, by the way, I'm glad you brought that up. If you want to use the box method, that's perfectly fine too. Whatever works, just do it. Because I don't, you know, if that's what you learned, then you should do it that way. Oh no, you do not. Oh, all right. Well, then you have to pick the thing you despise least. How about that? All right, let's put it that way. Take the thing you despise the least. But either way, whatever works is what you have to go with. All right. It's just like anything else. There's usually many ways of getting to the same answer. So you just have to pick the one that is the most direct. Okay. It's just like driving. You know, there's so many ways you can get to school. You take the path that gives you the least aggravation. I mean, really, that's the bottom line. All right. So let's look at this thing. Now, an inventor leaves his entire estate to his wife and son. The wife gets 2/3 of the estate and the son gets the rest, which is clearly 1/3. If the son's share is $500,000, what is the total value of that estate? So here's what we can do. Let's define X to be the value received by the wife. Actually, I can type this. It'll be a little quicker. X equals the value received by the wife. And then Y could be the value received by the son. When I say value, I mean the dollar value. Let's make that more clear here. All right, well, we already know one of these. Y is 500,000. What else do we know though? Now, this is the tricky part. Because the wife gets 2/3, and the son receives 1/3 of the estate. This means that the wife's share is double the son's share. That's the key to the whole thing. So therefore, we can write that x equals 2y. That was the hard part. And once we have both of those in place, because we already know that the son got 500,000, that means the wife must have gotten $1 million. And so, and it looks, I mean, you can tell that it is correct because she has twice as much as he does. And the total value of the estate would therefore be x plus y, which is $1 million plus $500,000 equals $1,500,000. All right, and that one is done. But this right here, right there, that was the challenge to the whole thing. So if you see a similar one on the exam, just look at those ratios. Now, what if they had each received half the estate? Well, then we could have written right here x equals y, and it would have been even simpler. So this right here, this line comes down to the ratio of one to the other. Okay, the wife gets twice as much as the son because she got 2/3 of the total and he got 1/3. All right, now this next one is interesting because it involves carpentry, a very hands-on application. I think you'll agree. Does everyone here know how to do this stuff? I sure don't. Are you handy with tools? No, that's okay because I'm not either. That's why I live in an apartment instead of a house. I can't do anything for myself. Little bit, yeah. I mean, you know what a screwdriver looks like. That's that's probably about, yeah. Yeah, potential. Yes, potential. I mean, I suppose anyone could learn how to do this stuff, but you know, you probably, it's the kind of thing you probably should have learned as a child. Maybe your father could have taken you aside and said, listen, here's a hammer, that kind of thing. If not, it's okay. That's why we pay carpenters to do this stuff for us. But anyway, but here, all we need to know is the size of the deck, not how it was built. So we're going to decide, it says here the cost of building the deck depends on the area. Now, of course, remember the area of a rectangle, which we're assuming this is, it doesn't specifically say that. But I think we can safely assume that it's not a trapezoid. All right, have you ever seen anybody's deck that was a trapezoid? No. In fact, do you even remember what a trapezoid looks like? That's this kind of thing. Yeah, one of those. That's a trapezoid. Okay, so now the first deck is 6 by 9, has an area of 54 square feet. You just literally multiply 6 times 9. It costs $2,160 to build. Now, what you could do here is just note that $2,160 over 54, and this is not absolutely necessary, but it's one possibility. $40 per square foot. The second deck is 9 by 12. This has an area of, if you multiply 9 times 12, it turns out to be 108 square feet because it's 9 feet times 12 feet. Well, that means that the cost must be $40 per square foot times 108 square feet. And if you multiply that out, 4320. Also, what you could have done is this. Note, the area of the 9x12 deck is double the area of the 6x9 deck. So it must cost twice as much, or 2 times 2160, which is 4320. You could have done it that way as well. You could have just noted that, oh, it's twice as big, or it has twice as many square feet, which implies that it must cost twice as much. Either way, you'll get the same answer. Okay, so you can figure out how much it costs per square foot, or you can directly compare the sizes of the two decks to each other. Either way, you'll get the same answer. Okay, so one more. This is one of those investment problems where the professor invests equal amounts in two stocks, X and Y. So let's let X equal amount invested in stock X, and Y, of course, is the amount invested in the stock Y. And what do we know? Well, he invested equal amounts in both stocks, which implies that X equals Y, which is great. That helps a lot. Now, how about the investment part? Because he invested, the dividend received from stock X is 0.04x. In other words, 4% of the amount invested in stock X. Now, if you notice, it's being multiplied by 0.04 because, of course, if you remember, 0.04 is the decimal equivalent of 4%. Okay, so you should always use decimals in an equation. All right, so as soon as you see a percentage like that, don't use 4 in the equation, use 0.04. And equivalently, the dividend received from stock Y would be, because it says in the problem up here, Y pays 6%. So therefore, Y, the dividend is 0.04 Y. Okay, so we don't have to repeat that. So the total return to the stocks is therefore 0.04x plus 0.06y. But we know that that adds up to $270 from here. So we now have two equations and two unknowns, which is what we need. X equals Y and this expression or equation. And so now look how easy this is. Watch this. Using the method of substitution, we can replace all the x's in the second equation with y's, since x equals y. So we'll have 0.04y plus 0.06y equals 270. We can add those together to come up with 0.1y. And now, how do I get rid of that? I divide both sides by 0.10. And dividing by 0.10, by the way, is the same as multiplying by 10. So I end up with y equals 2700. And since x equals y, that implies that x also equals 2700. Okay, so the professor invested $2,700 in each stock. And they didn't ask for this, but the total investment is, of course, $5,400. It's possible that this could happen on the actual test, that it's not enough to figure out the individual amounts, that you need the total as well. But here, they just wanted to know what each one was separately. All right, so we're now 100% ready to do the midterm, which you'll hopefully be doing this weekend or whenever it's convenient. Don't wait till the last minute. All right, here's what we're going to do next. We're going to start a new chapter, a completely new chapter. Now, this chapter is very interesting because it involves something that everybody will encounter sooner or later. And what could that be? That would be interest rates. So now I asked this question of the other class, and it took them a while, but as college students, what would be the one thing that you most likely have encountered already that involves interest rates? That's it, exactly. Because when you borrow money from the student loan program, they're not just giving it to you. You not only have to pay it back, yes, but you also have to pay interest. So the amount of interest that they're charging you will determine how much you have to pay back during your lifetime. All right, so it's important to understand how this works. Now, another area that you might have already run into is credit cards. Does anyone here have a credit card? Which, by the way, you only have to be 18 to have a credit card. The reason for that is because, yes, there you go. It's probably a good idea to have at least one credit card, even if for no other reason than to pay for emergencies, like if your car breaks down in the middle of the night and you have to have it towed away. That's okay too. The debit card gives you access to all the money in your checking or savings account. And it also stops you from spending more money than you have. That's good too. But the debit card doesn't charge you interest, though. That's the nice thing. The credit card does. So in other words, if you do not pay off your balance every month, they will charge you interest. And it can be quite a bit of interest, as a matter of fact. But also when you're out of school, you may run into other situations like, what if you decide that it's time to buy that brand new car you've always wanted? Are you likely to have $25,000 in the bank to buy the car? No. Maybe if you're a really good saver. Yes, you can get a loan. And also when it comes time to buy a house, does anyone know the name? There's a special name for a loan that's used to buy a house. Does anyone know what it is? A mortgage. Yes. So you're really on top of this stuff, aren't you? Yes, a mortgage is the name of a loan that's specifically meant to buy property, including homes. That's right. So if you live in a house, your parents probably have a mortgage unless they've paid it off. It's not likely they would have had enough money to buy it outright, so they would have had to go to the bank and get a loan, and they pay a mortgage amount every month until it's paid off, which typically takes about 30 years. Because houses are so expensive. Right? Yeah, 30 years. Imagine that. 30 years paying for a mortgage. But when it's over, ooh, boy, that's time to celebrate. All right. But anyway, so what we need to be able to do is understand how interest rates are calculated and how that affects the cost of borrowing, as well as how does it influence what we earn when we invest our money. Like if you put your money in the bank or something along those lines, you'd like to know how much money you're likely to have when you need the money back. Okay, so we're going to look at some very interesting ideas in this chapter. So we're going to start by looking at, hold on. Oh, here we go. What we're going to do is start out by asking ourselves the following question. Suppose you do decide to borrow money. there are different ways in which you can borrow money. So like I opened this question to the other class and they didn't really get what I was trying to address here. Why, if you've ever noticed this, the interest rates on credit cards are significantly higher than the interest rates on car loans. Well, if you didn't know that, you do now. The question is why? Why would the bank charge you so much more money for a credit card than for a car loan? I mean, it's the same person borrowing. If you went to the bank and said, listen, I need a credit card and a car loan, they might say, well, the car loan will cost you 8% and the credit card will cost you 18%. Why is there such a big difference? All right, here we go. That's a possibility. They're not very long loans, but what else is going on with a credit card? Well, let me show you the magic word. And then when you see it, you'll say, oh, I see what you mean. The magic word there is risk. Okay, risk. Now, when I say risk, I mean from the perspective of the bank that's lending you this money. What is the one thing that banks worry about the most when they lend money?
They don't want to lose it.
That's right. They want to make sure you pay that money back. Now, here's the thing. How do they know that you're going to pay it back? The answer is they don't. They're taking a gamble with everybody who walks into that bank. So what they try to do is they try to figure out how much risk there is involved in each type of loan. And the riskier the loan is, the higher will be the interest rate. Okay. So the greater is the risk of a loan, the higher will be the interest rate charged. That's how it works. More risk, higher interest. Because the bank is trying to make money. And if people don't pay their loans, the bank needs to somehow survive by charging more interest. So that if they do have a lot of people not paying, at least they have all this interest that helps them cover their losses. But then that raises another question. Why is the credit card then so much riskier than a car loan from the bank's perspective? What's the difference? All right, here's the way to think about it. Oh, somebody's got to, okay, go ahead, Noah.
Well, with a credit card, you basically can spend more money than you have and they just send you a bill each month. So they don't take directly from your account.
True. Now with a car
Basically,
loan,
you spend way more money than you can actually pay them.
that's true. You can run up.
You're in debt, but some people can never pay off their credit card debt because they
Sure.
aren't smart enough to know not to spend more than they have.
Right, you do run into that, and it's very unfortunate when that happens. But here's what I was thinking of. What happens if you buy a car and you don't make the payments to the bank? What can the
They can
bank?
take the car.
That's right.
So collateral, basically, that would be called.
Yes, the car represents collateral.
You
For
also
them.
take houses. For the bank can take your home, for example.
That's right. They can also take your house if you don't make the payments. So, is that possible with a credit card, though?
No.
Not really. I mean, it depends on what you bought with it. But I mean, realistically, let's say you use your credit card to go on a really nice vacation, and then you can't make the payments. Well, there's nothing for the bank to take back. So if you don't make the payments, they just lose all that money. Now, in principle, they can take you to court and all this and that, but it's often a very expensive process. So what they often end up doing is they simply write it off in their taxes. They're actually allowed to write off losses from bad debts in their taxes, and then they just, write it off. And because they know that there's always some people who will not make their payments. They've already kind of priced that into the cost of doing business. They understand from experience how likely this is to happen. It's not good, but at least they know what to expect. And so they compensate for themselves by charging a higher rate that reflects how much risk there is with credit cards versus, let's say, car loans. So if you don't make the payments, The bank can repossess your car and sell it, which significantly reduces the risk of the car loan because no matter what happens, they'll get some of their money back. The credit card, pretty much if you don't pay, they just lose the money. End of story. Okay. And that's why they have to charge so much interest. Now, if we look at a house, oh, right. And so credit cards are much riskier to the bank than car loans. This is why interest rates on credit cards are higher, and not just a little higher. They're a lot higher for the most part. If any of you do have a credit card and you look at your statement, you'll see that the interest rate they're charging you could be really, really high. I mean, like 10, 12, no, more than that. It could be as high as 20%, for God's sake. That's a lot of interest. But it's because they don't know for sure that you're going to pay it back. And there's not much they can do about it if you don't. So, but at the other extreme, we have houses. Now, we know the bank can repossess a car or a house, but why is it easier or better for them to repossess a house? What is different about the value of a house over time compared to the value of a car?
That car is going to break down. It's going to break down eventually. The house, you can live in that forever, seemingly forever.
That's right. That's exactly right. The value of the house increases over time, whereas the value of the car decreases. So if the bank repossesses your house, they could actually make a profit from it because they might be able to sell it for more than you paid for it. But that's not going to happen with a car. So therefore, even though they're both relatively safe loans, the bank can charge you even less for a mortgage than they can for a house. Now, with the other class, I was showing them some actual real world examples of this. But before we did that, we had a nice little poll that I just want to ask just out of sheer curiosity. I don't expect you are constantly following the financial news and all, but I want to ask you one question just out of curiosity. And that question is, whoops. I have to type it in. Are interest rates at unusually high or low levels at this point in time? Okay, high or low? Let's find out. Now, if you don't know, you don't know. I mean, that's all there is to it. But I was just wondering if you have seen this in the news, or if you if you have any interest in this area. All right. We have some people who are still thinking about it, like, I'm not sure. Well, no, you're not. Okay. I mean, I get it. You're not like constantly reading the financial news, although that will change when you start earning some real money. Right now, you're like, whatever. But okay, so it looks like everyone who wanted to vote is pretty much voted. Oh, he does. Oh, that's why you know so much about mortgages, and that's good. You see how it rubs off on you, and all of a sudden, before you know it, you become a finance guy too, or a finance lady, I should say. So yeah, I mean, but having it on all the time, you're hearing this, and you have the opportunity to think about it and absorb it. So you are then aware of the fact that interest rates are actually at very low levels right now. So, well, that's, I see most people didn't know that, but that's okay. Interest rates right now are at unusually low levels by historical standards in the United States. Now, that's very helpful if you need to borrow. It's not going to help you if you need to invest or save. Okay, so when interest rates start creeping back up again, then the advantage swings back to investors who are saving, and it starts to become more expensive to borrow. So if somebody needed to buy a house, now is the perfect time to buy it, because interest rates will probably never reach these levels again during our lifetimes. They're really, really low. So now what I also wanted to do is take a quick peek, just out of curiosity, to see what rates are out there. For example, we mentioned that car loans are typically more expensive than mortgages. So why don't we go out there and find out if we can see what are typical mortgage rates in 2021. Let's see, what do we have here? Okay, so a 30-year rate is looking at around 3.2%. 15 years around 2.5%. Okay, now let's take a look at typical car loans. All right, so remember, you're looking around 3-ish for these. How about what are typical car loan rates? Okay, it's not, the difference isn't as much as I actually expected. Instead of being the very high 2s or low 3s, we're looking into the low to mid 4s here. And again, we understand why, because the car loans are riskier than loans for houses. Okay, so yes, you would expect to pay a little bit more interest for a car loan because it's a little bit more risky. Now, if you notice with a car loan, you can take it out for anywhere from 36 to 72 months. From the bank's perspective, they would rather you pay it back quicker, and so therefore they'll offer you a lower rate of interest. For 72 months, well, that's 72 payments that they have to worry about, so they'll charge you a little bit more to compensate them for the risk. But those are pretty low. In fact, you know what? Let me see if I can find a chart that shows how rates have changed over the last so many years. I'm going to find a chart that shows interest rates. Okay, so this chart is sort of an indication of what rates have done in the last 50, 60 years. And you can see they've been very high and they've been very low. And so interest rates do go through these cycles where they go up and down and up and down. So down here, we're pretty much on the axis. We're pretty close to zero. Okay, so it's not like we've never been there before, but prior to, by the way, this range in here was the result of the housing crisis when housing prices collapsed. But prior to that, you can see rates were typically quite a bit higher, as a matter of fact. You have to go back to the 60s and 50s to find rates that are even close to being where they are now. Okay, so anyway, so with all that being said, what we're going to do, one more thing. I had a couple of other websites here. I just wanted to show you. I was able to look up typical rates, unless I've lost them already. Wouldn't surprise me. I've got so much stuff here. All right, what I wanted everybody to see is what rates are being paid on savings accounts. So if you have a savings account, you know that you just leave the money there and you do not have check writing privileges. But let's see what kind of rates we're looking at. Ooh, 0.4%. Okay, so if you're the saver, they're giving you 0.4%. And guess what they're doing with that money? They're lending it out to somebody who wants a car for 4.5%. What's up with that? They give you 0.4% and then they charge people 4.5%. Well, that's how a bank makes its money. They borrow from you at a fairly low rate of interest, and then they lend it to somebody else at a higher rate of interest. But keep in mind, they're the ones who are taking on all the risk. That's what they're being compensated for the risk. Because your money is your money. They have to give it back to you. But if they lend it out to somebody who doesn't pay them back, they could find themselves in a lot of trouble. So there's going to be this gap always between how much you can earn in interest and how much you have to pay on loans. So, and it goes through cycles, as we've seen. Sometimes rates are very high, sometimes they're very low. Right now, they're very low. Now, I'm going to ask this is the second poll that I did with my other class. And this is interesting. This is something we'll discuss later on. But, and again, this revolves around, do you pay attention to the financial news? Interest rates, what we want to know is what organization is actually responsible for setting interest rates in the United States economy. So who sets interest rates in the US economy? Okay, here we go. The House of Representatives, let's say, the Senate, the Federal Reserve System, and Amazon.com. How about that? All right, here we go. Let's check out this poll. All right. Well, we have an overwhelming majority here. I have to tell you, I'm pretty impressed because that is absolutely correct. The Federal Reserve System is they are the central bank of the United States, and they're the ones who ultimately set interest rates in the economy. So I told the other class, and we'll do it here too, when we're done with this chapter, I think what I'd like to do is show you a short video about the Fed, because it's the kind of thing that you should all be aware of, because it will have a major influence on all the decisions that you make throughout the rest of your life. And it's just plain interesting. Okay, so the Fed, you hear it called the Fed in the news. Every time the Fed says or does anything, everybody pays close attention, because they're the ones who are choosing where to send interest rates. So people might think, well, they may be setting rates higher next year, or maybe they'll be lowering them further. It makes a huge difference to the economy what they decide to do. Anyway, so that's good. So I'm pretty impressed that everybody is comfortable with that knowledge. So anyway, but let's get back to the notes. We're going to start by introducing a concept called simple interest. And we also have a few other key ideas that we need to introduce here. For example, the word principal will be used to represent how much we borrowed or lent. So the interest that we earn or pay depends on several factors, among them being the principal, or the amount that we borrowed or lent. And of course, it makes sense that the interest also depends on time. And of course, ultimately, the rate of interest. Oh, you know what I just realized? You know what we forgot to do? We forgot to look up what are typical credit card rates. We looked at a lot of interest rates. We missed that one. So let's try that real fast right now. The average is 17.87%. Look at that. You could borrow a car, pay for a car with 4.5%, or a house for 3.3%. A credit card, 17.87%. Oh my God. Yeah, you get the idea. Okay, so use those credit cards sparingly. All right, now we're going to also introduce some variables that we'll be using throughout the chapter. So for example, P will be used to represent principal, which makes perfect sense. Now R will be used to represent an interest rate. And the key here is we pay close attention here. This is a percent. R is always expressed as a percent. Specifically, it's the percentage of the principal that is either earned by lenders or paid by borrowers. So it's an interest rate. It's a percent. All right, then we've got a few more that we need to introduce. For example, what else do we need to know? Well, we're going to introduce a concept. Here's T. T just means time, which, by the way, T is always measured in years. Okay, so if we have a situation where the time is less than a year, it will be expressed as a fraction. Okay, for example, 6 months will be thought of as a half of a year. Now, in this book, for some oddball reason, they chose to represent what we call future value with the letter A. What is future value? That's how much we will either pay or receive in the future. So on top, you see I drew up a quick example. If we put $1,000 today in the bank, and let's just say for some reason, they're paying a lot of interest, in 5 years that our balance is $1,120. That means we will say that the future value of $1,000 is $1,120. All right, in other words, $1,000 invested for 5 years will be worth $1,120 in the future. And you can see that's an important thing to know. If you're saving for, let's say you need to buy a car or a house or anything, or you're saving for your retirement, you have to understand how much your money will be worth in the future when you invest it. We're going to see exactly how to do that. Now, there's one more at the bottom here that we need to pay attention to. If you notice, this one also involves interest, I for interest, but this time it's not the percentage, it's the actual dollar amount that we're earning or paying. So I've summarized that on the bottom here. R means it's a percentage, and I means we're looking at a dollar amount. We have to be careful to make a distinction between the two of them. All right, now we're going to tie all these together for our first equation of the chapter. All right, I know you were dying for this all this time to see our first equation of the chapter. And it's a very nice, simple little formula, but we'll get a lot of use out of it. All right, it'll be very different than what we've just been doing in chapter 6 and 5, that's for sure. So let's take a look at it. This formula is designed to tell us how much simple interest we earn by lending money or how much we pay by borrowing it. And you see it consists of 4 terms. The dollar value of our interest equals the principal we invested times the rate of interest, which is a percentage, times the time over which we have invested this money. All right, very simple formula. I'm sure you will agree with me on that one. So what can we do with this formula? All right, well, let's look at some examples. Let's say, for example, we put our money in the bank. Oh, you know what we have to do? We have to introduce I'm looking ahead a little bit to see where this comes up. All right, I'm just going to introduce it right now because we'll need it later on anyway. I've forgotten where this pops up. We will sometimes in this chapter run into this concept of what's called a certificate of deposit. This is a savings account where the money must be left on deposit for a fixed length of time. Now, you might say to yourself, why would I ever put my money in an account like this where I have to leave it there for a certain length of time? This pays more interest than a traditional savings account. So you do see these. And the idea here is that if you can commit to leaving your money there for a certain length of time, they'll pay you more interest than you'll get on a regular savings account. Would you have to mean it? If you say, I'll leave it here for a year, you cannot have it back for a year, no matter what. Well, I shouldn't say that. There are provisions. If you have a genuine emergency, they'll give you your money back. But for anything short of that, you have to leave it there. Okay. And if you still insist on having it back, they'll give it to you, but they'll subtract so many penalties that you'll end up with less money than you started out with. So for all practical purposes, when you put your money in a CD, you're committing yourself to leaving it there for a fixed length of time, which can be anywhere from 1 year to up to even 10 years. So just out of curiosity, with my other class, we went ahead and looked up typical CD rates. And now I'm sure I've lost it. I've long since lost it. Well, you know what? We'll just have to look it up again. Okay, so here we go. Now, these are not very impressive, but you can see it's still a little bit better than what you might get in a savings account. But it's still kind of pathetic at this point in time. There was a time when a 5-year CD might have given you 7 or 8%. Now we're looking at 1/3%. But that's again because rates are so low right now. All right, so I just wanted to mention that concept because it will show up in our examples. All right, so let's say, for example, let's look at this case. An investor deposits $1,000 in the bank for a year. And this bank, just to keep it simple, I've made 3%, which we know is too high, but let's say we could earn 3%. How much simple interest will we earn during that year? Well, we're going to have, if you look at this formula, we have $1,000 principal times 3% interest, and the money stays in the bank for a year. If you multiply all these three out, you'll get $30. And also keep in mind, you still have the original $1,000. So the total balance in your account at the end of the year will actually be $1,030. Okay, $1,000 worth of the original principal plus another $30 in the in interest. So that leads us up to the next slide where we're going to look at a formula, our second formula, which tells us how to calculate future value when we are earning simple interest. And that's coming from here. You see that we had $30 worth of interest, but a total amount at the end of the year of $1,030. So in the next slide, you'll see that what we've just done is calculated our future value. In other words, the balance at the end of the year is called the future value of the original principal of $1,000. And so you can see this can be calculated with two equivalent formulas. The first one is the simpler one because all you're doing is noting that you're taking your $1,000 worth of principal and adding another $30 worth of interest for a grand total of $1,030. But if you look up here on the top, you can see that there's another equivalent version of this we could create. If you start out with A equals P plus I, and recall that I equals PRT, I can combine these and do a little rearranging algebraically to come up with the second equation. And so either one of these will give me the same results. Okay, and you can prove it by plugging in the same numbers we just had. 1,000 times 1 plus 0.03 times 1 does in fact, it reduces to 1,000 times 1.03, which is of course 1,030. All right, are we all set here? So the future value of that sum is 1,030 because we keep our original $1,000 worth of principal, and plus on top of that, we earned another $30 worth of interest. Now, I do want to point out here, and again, this involves the time element. If we have a time frame which is less than a year, we're going to adjust t to become a fraction of a year. For example, if we're borrowing or lending money for less than a year, for 6 months, for example, we would replace t with 0.5 years. And for 3 months, we would use 0.25 years. You know, and you can figure the rest of them out too. This is just 1/2. This is 1/4. 1 month, for example, would be 0.08333 because that's the value of 1/12. Okay, so you get the idea. So the t is in years. A fraction means you're looking at a partial year. All right. Now, what if we had a case like this? Here's an example. The investor deposits $1,000, but for only 6 months in a bank account that pays an interest rate of 4% per year. So 2 things we have to note. Number 1, make sure you convert that percentage into a decimal. And number 2, 6 months means half a year. So ultimately, we end up with a result that we have $20 worth of interest after 6 months. Now, we're going to do something interesting here. We're going to take our original formula, I equals PRT, and we're going to rearrange it algebraically to solve for other variables that might be of interest to us. What do I mean by that? Let's say, for example, we don't want to calculate the interest, but the principal. What could we do? Well, starting with the original equation, if you divide both sides by RT, you'll see that we end up with this equation. So in other words, if we know the interest and the interest rate and the time, we could figure out how much money was lent or borrowed in the first place. And so you're taking your original equation and rearranging it to solve for P. All right. Not bad. So in other words, already this formula is giving us an alternative second approach or second variable that we can solve for, which is now principal. And so in fact, why don't we do this? I'm going to show you the example and I want you to tell me what the correct answer is. Okay. So let's say a homeowner is borrowed from a bank to finance various repairs. The simple interest paid on the loan is $20,000. The rate is 4%, which remember converted to 0.04, and the principal will be repaid in 5 years. How much money did the homeowner borrow? Which means, what is the principal of this loan? And so based on the formula up here, why don't you take a minute and tell me what you come up with. All right, anyone have a number? Ooh, oh, here we go. Somebody has it. Beautiful. Okay, so you've got 4,000. Let's check this out. Oh, whoa, okay. So I'll tell you what. I think I know what probably happened. When you do this down here, I've written out how to do this with your calculator. Did you use parentheses when you divided by these two terms?
I
Okay, try it again with the parentheses and see what happens. All right. So in other words, you want to make sure it understands you're actually taking 20,000 and dividing by 0.2, which is the product of 0.04 and 5. All right. So is everybody getting 100,000 for their answer? If not, make sure you follow these steps with your calculator. All right. So we're going to stay here until everyone gets this because this is really important.
think I accidentally divided by 2,000, put 2,000 divided by 0.2 because now I got
Oh,
10,000.
that's a possibility too. Okay, if you made a typo, of course. So did you get the right answer then? By the way, if you notice in this calculator, it does fill in the commas for you. You don't have to type them yourself. So like this 20,000, it appears in the calculator, it actually has the commas, which is kind of nice because, you know, it's hard to keep track of big numbers without those commas. All right, does everyone else have, so do you have the answer, Britt? Oh, you do. Okay, good. Everyone else? Perfect. All right. Well, that's good. So, I mean, once you've done this once, you should get them all right. There's no problem. But just always be careful with those parentheses, especially when there's multiple operations going on. All right. Now, if we can rearrange this formula to solve for P, what's to stop us from solving for R? The answer is nothing. We just rearrange it algebraically, and there you go. A whole nice new formula for interest rates. All right. So R equals I over PT, and you can see why if you just divide out both sides by PT. Let's do an example. Now, I just realized this next example is the one that has the CD, but it doesn't change the formula. It's just the investor here is putting $1 million into a CD for a year. During that period, the investor earns $20,000 worth of simple interest. What rate of interest are they paying the investor? So remember here, the principal is $1 million, the time is a year, the interest, the dollar amount of the interest is 20,000. What's the interest rate? All right, let's see what you can do with that one. All right, anyone have a number? 2%, perfect. That's exactly correct, all right? In the denominator, you have 1 million times 1, which is, of course, just 1 million. So you're basically dividing 20,000 by 1 million, which is 0.02 or 2%. Perfect. Well, that was easy. Now, we're ready for the last one. Now, there's altogether, so far we've calculated I, P, and R. The only thing we missed was T. So as it turns out, of course, we can rearrange this formula to solve for T. It's just about algebra. All right, so let's do that. So T equals I over PT, PR rather, and again, it's just because we divided out P and T, R from both sides. And T, remember, is always expressed in years. So let's try this one. Now, an investor puts $100,000 into a CD that pays an annual rate of 3%. This investor earns $30,000 in simple interest, but how long will it be until the CD matures? Okay, now this time, you notice how it just says CD. It doesn't tell us how long this will last. That's what we need to solve for. How long does the money have to stay there to make $30,000 worth of interest? All right, do we have any answers? 10 years, perfect. All right, and here's why. Because we've got $30,000 in the numerator. In the denominator, we have 100,000 times 0.03, and that gives us exactly 10 years. Perfect. All right. So now we've kind of exhausted all the possibilities here for this formula. What's coming up next is a fairly complicated topic that I told the other class that, you know, when we got to this point, that maybe we should save this for Monday, because it's something I need to build up to in small stages. And also, if we stop early today, that gives you extra time to work on the midterm. So I'll tell you what, why don't we stop right here? And we will pick this topic up again on Monday. But in the meantime, don't forget to do your midterm. Okay. Now, if you forget on Monday, you wake up and say, oh my God, I haven't done it. You still have until midnight, but just, try not to put it off to the last minute. All right. So there's no more last minute questions. Why don't we stop right here, and I'll see everyone on Monday.
Bye.
Okay. Bye. See you later.
Bye, thank you.
Okay. Goodbye. See you later.